If you saw the thumbnail, you would have noticed that I said compounds are never made up of just one element, but that's way too simple, and a better definition would state that a compound is a substance that is made up of two or more elements chemically bonded together. So when it says two or more elements, you're basically saying it's made up of atoms of different elements. So basically each compound is made up of atoms that come from different elements. And of course they're chemically bonded together, so this could be an ionic bond or a covalent bond. Now, taking a look at a few examples, let's take fluorine, F2. It has a covalent bond between its atoms. However, it's made up of the same element. It's not made up of different elements. It's made up of only fluorine, and therefore we don't consider this a compound. Same thing with oxygen, phosphorus, and sulfur. Although they all have covalent bonds between their atoms, they're all made up of the same element. They're not made up of atoms that come from different elements, and therefore they're not considered compounds. And when you look at the definition of a compound, and that is made up of two or more elements, and then you look at the substances that we just talked about, all of them were made up of a single element. Like oxygen is made up of only the element oxygen, sulfur is made up of only the element sulfur, and therefore these are not made up of two or more elements, and therefore they're not considered compounds. Now, looking at these examples on the right, let's take hydrogen chloride. It has a covalent bond, so that's good, and it is made up of a hydrogen atom and a chlorine atom. And therefore this substance is made up of atoms that come from two or more elements. And therefore we can say this is a compound. Same thing with water. It's made up of an oxygen atom and two hydrogen atoms. Therefore, this substance is made up of two or more elements, or their atoms comes from two or more elements, and therefore we can say it's a compound. And that's the same thing with ammonia, carbon dioxide, and organic compounds such as ethanoic acid. They're all made up of two or more elements, and therefore they can be considered compounds. And now you can see the difference between these examples on the right and the ones on the left. The ones on the left being made up of atoms that come from just a single element, while these ones are made up of atoms that come from different elements, and therefore they can be considered compounds. Now, coming on to molecules, we can define a molecule by saying it is a substance that is made up of two or more atoms chemically bonded together. And here it's two or more atoms. It doesn't care if it's made up of two or more atoms of the same element or two or more atoms of different elements. All it cares about that it is composed of two or more atoms chemically bonded together, but here it's chemically bonded together by covalent bonds, making it different to compounds, because compounds can be made up of both covalent or ionic bonds. And now looking at the same examples again, fluorine, oxygen, phosphorus, and sulfur, they can all be considered molecules because they're all made up of covalent bonds and they're all composed of two or more atoms, and therefore they can all be considered molecules. And the same thing with the ones on the right, hydrogen chloride, water, ammonia, carbon dioxide, and ethanoic acid. They all have covalent bonds, not made up of ionic bonds, and they all have two or more atoms, and therefore they're also considered molecules. And this is where some people might say that all compounds are molecules, but not all molecules are compounds, because taking a look at these molecules that we said, they're not compounds, so we know that not all molecules are compounds. However, these compounds, we said they're also molecules. So can you say that all compounds are molecules, but not all molecules are compounds? To answer this, let's take a salt, sodium chloride, NaCl for example. Would you classify this as a compound or a molecule? I'll pause for a few seconds and I'll let you decide. So, taking the definitions we talked about earlier, you'd probably classify sodium chloride as a compound because it's made up of two or more elements chemically bonded together by ionic bonds within the giant ionic lattice structure. And therefore we normally refer to sodium chloride as an ionic compound. And it's not considered a molecule because although it has more than one atom, it's made up of two more atoms, but the problem is they're not covalently bonded together, they're ionically bonded together, the ions within the structure of sodium chloride. and therefore you won't consider a molecule. And to answer the question, are all compounds molecules? Well, now we know no, because salts like NaCl are compounds, as we just stated, but they're not molecules. So not all compounds are molecules. Now, from the definition of a molecule, we clearly stated that sodium chloride is not a molecule. But to have a different look at this, to think about it in a different way, let's take a cup of water, and it contains many water molecules or H2O molecules. And taking this cup of water, you can get down to the single H2O. You know that in that cup of water there is a distinct molecule of H2O, that single H2O molecule. And same thing with, like, let's say a container of carbon dioxide, that a container containing molecules, or now as we defined before, we said carbon dioxide can be both a molecule like compound. So it contains carbon dioxide. You know you can come down to a single carbon dioxide molecule or compound. But when it comes to salts, even in the smallest grain of salt, even the smallest grain of NaCl, you'll have tons and tons of sodium and chloride ions electrostatically attracted to each other in a giant ionic lattice structure, even in the smallest grain of salt. And therefore you can't really break down these salts that have these giant ionic lattice structures into a single molecule of NaCl, or other salts, that you can't break it down into that single molecule of NaCl. And that's why we don't consider NaCl a molecule. And the reason why we write NaCl is just to show the ratio of sodium ions to chloride ions, which is 1:1. And that's more of a different way of thinking why we won't consider sodium chloride a molecule. Now, the problem that arises with molecules is that, like many other terms, it can have different definitions attributed to the single term. But for A-level chemistry, you don't need to know about these different definitions of a molecule. Make sure you understand and you stick with the first one, which stated that a molecule is made up of two or more atoms chemically bonded together by a covalent bond. However, I wanted to take a look at one other definition that we actually used when we took that different view or look into classifying why NaCl is not considered a molecule. And this definition still works like the first definition we talked about. It's correct. It's just a different way of looking at things. And it's basically a different way of classifying substances as a molecule. So looking at this new definition, it states that a molecule is a group of two or more atoms, so it starts off in the same way, and then it forms the smallest identifiable unit into which a pure substance can be divided into. So it's basically stating that any pure substance that has many molecules within it, it can form the smallest identifiable unit. So you can break that pure substance into the smallest molecule or the smallest unit that makes that pure substance. And also, that smallest identifiable unit retains the composition of that pure substance, and it also retains the same chemical properties of that substance. And the three key parts of this definition is that this molecule is the smallest identifiable unit of a pure substance. It retains, so the smallest identifiable unit retains the composition of the pure substance and the chemical properties of the pure substance. So taking the example of that cup of water again, so that cup of water contains many H2O molecules, as we said, and we know that you can get down to that single molecule of H2O from that cup of water. You know that exists. You can get down to that single molecule of H2O, or in this case, the smallest identifiable unit of that pure substance, which is a single molecule of H2O. So that ticks that box. Does H2O retain the composition? And yes, it does. Why? Because it still is made up of two hydrogen atoms and one oxygen atom. So it retains the composition, and also it retains the chemical properties, because a single molecule, or the smallest identifiable unit, in this case, which is a single molecule of H2O, will react in the same way as a bunch of H2O molecules. and therefore using this definition we can use it to classify water as a molecule. And the first definition also classified water as a molecule, so this definition works for water. Now let's think about sodium chloride. So when it comes to sodium chloride, it's not a molecule, even using this definition. Why? Because as we said, the smallest grain of salt still contains that giant ionic lattice structure, which is made of many sodium and chloride ions. And you can't get down to that single molecule of NaCl. And therefore, because this molecule states that it needs to be made up of two or more atoms that form the smallest identifiable unit of a pure substance, and therefore sodium chloride just doesn't do that, because the pure substance is that giant ionic lattice structure made up of many sodium ions and chloride ions, but you can't get down to that single NaCl smallest identifiable unit, and therefore you won't consider sodium chloride as a molecule, even using this definition. And this shows that the first definition we talked about and this definition both work. It's just different ways of looking at things. One is more like just memorizing the definition with the first one, and then classifying substances into a molecule or not a molecule. And this one is more a logical approach into saying, oh, does it get down to that single molecule? And if not, then it's not a molecule. Both work. However, for A level, make sure you stick with the first one. It's the easiest one, makes sense, and that's all you really need to know. This one, I just wanted to highlight it just to show that there are different definitions for a molecule. Finally, I wanted to give a brief overview of noble gases when we're trying to classify them as molecules or not molecules. Now, so taking these helium atoms and neon atoms, which are noble gases, they're made of one atom. They're made of individual atoms. Therefore, they're not made of two or more atoms, and also they're not covalently bonded together. And therefore, they don't satisfy any one of them. They're not bonded together covalently, or they're not made of two or more atoms, and therefore they're not considered as molecules. And that's what you use for A-level chemistry, and that's the right thinking. That's how you should think about it. But again, because molecule is a controversial term, different definitions can be attributed to it. Some definition or another definition would say that they are molecules, but they're called monoatomic molecules. So they're molecules because they can be brought down to that single identifiable unit. You can get down to the single helium atom, and therefore they consider it as that certain definition would consider it as a molecule. However, whatever you call it, monatomic molecules or not or you're not thinking of it as a molecule, it's the same thing. Like, they still exist as individual atoms in reality. Whatever you call it, they still exist as individual atoms. However, I want to make sure that this is not really important for A-level chemistry. It's just different definitions of a molecule, and that's why it can be a bit confusing. But make sure you think about it as the first definition I stated, and therefore for A-levels you will not consider this as a molecule. You'd consider them just as atoms. However, as I said, different definitions can bring the point of that it can be broken down into the smallest identifiable unit, and therefore that definition might consider it as a monoatomic molecule. However, this is not very important to know about. Make sure you understand the basic, the first definition I said, and therefore you would classify this as not a molecule. So coming to the end of the video, this just shows the two definitions we mainly talked about within the video, and make sure to learn them, understand them, so you're able to classify different substances into either a molecule or compound, or even both. Make sure if you have any questions to ask them and write them down within the comment section. And also, I might be sticking down a website or a few files in the description just for more information for anybody who's curious. Thank you very much.